Hi everyone, this is Sangeetha, working as an assistant professor in Department of Mathematics, Prathyusha Engineering College. I welcome you all for a technology upgrade meeting. Today my topic is application of mathematics in movie graphics. Movie graphics put the math and the art of digital images in motion. They rely on high-level mathematical concepts to stimulate familiar visuals, auditory, and movement patterns. Math touched everything from lightings to color to shape. It's also used in the storage and transmission of the graphics. Movie graphics often incorporate vector space in three dimensions. We all have marveled at the incredibly lifelike computer generated images in the movies. What most of us don't realize is that the dinosaurs of Jurassic Park and the wonders of Lord of the Rings would not have been possible without mathematics. So, in today's session, we are going to see some of the graphics tools which are used in movie graphics. Setting the scene. The first step in creating a computer generated movie is to create the character in the story and the world they live in. Each of these objects is modeled as the surface made up of connected polygons. The vertices of each triangle are stored in the computer memory, and it is important to know which side of the triangle is on the outside of the object or character. This information is encoded in the order of the vertices are stored in according to the right-handed screw rule. Ray tracing. Ray tracing is the act of using the path that a light takes through pixels to create images. It simulates the effects that the light rays have on the object they encounter. Images created with ray tracing are usually of better quality and have higher degree of realism, but take longer to compute and more computing power. So, ray tracing is most often used for creating still images. Quaternions, a set of numbers that comprises a four-dimensional vector space with a basis consisting of real number 1 and three imaginary units ijk that follow the special rule of multiplication and that are used especially in computer graphics, robotics and animation to rotate the objects in three dimension. So quaternions and ray tracing plays a vital role in graphics. Bringing images to life. For this, we need to move the object or create motion on the object. For that, we are going to use two important tools in computer graphics that are deformation and interpolation. Interpolation and its techniques of key forming involve specifying an object initial and finishing shape, position, and getting the computer to work out the stages in between. Deformation. Deformation are a way of creating a complex objects from simpler one. For example, a cloth falling over a deformed sphere can be derived by mathematically manipulating the same scene involving an ordinary sphere. Both the deformation and interpolations require fast and stable mathematical techniques and quaternions related methods. Motion capture, a data collection technique in which the movements of people and objects are tracked, recorded, and rendered to create animation as for a video game. For example, here the data is captured from the movements of reflector attached to different parts of the body, and the skeleton is mathematically fitted to the data. Conclusion. Many of today's movies wouldn't be possible without the geometry of ray tracing or quaternions spinning objects in space. We will be aware that a huge variety of creative talent goes into making a successful movie to writers, directors, actors, costume designers, prop builders, and the list goes on. But one name is often missed of that credit list, that is mathematics. Hope the session is useful. Thank you for watching. Thank you all.